Okay, I'm back. So, yeah, take like another minute, think about this problem. Really, everything we've done is similar. It's just the only difference in this problem is the empirical rule that it's talking about. So, we don't have that much time left, actually. I'll just get right to it. So, we know that the mean is given by 8. You know that the standard deviation is 2. So, with this, it says you only have 3 minutes to make it to class. What is the z-score for the 3-minute trip? Well, that would just be 3 minus 8 over 2, which is negative 2.5. And it says, using the empirical rule, what is the probability that it takes less than 14 minutes to arrive to class? So before we get to the empirical rule, I just want to go over this next problem. Part C is just asking you, what is the probability that it takes less than 3 minutes to arrive to class? So that is just the probability that x is less than 3. And that's just the same as the p-norm of 3. And then you specify the mean to be 8 and the standard deviation to be 2. And then similarly, it says, what is the probability that you're between 7 and 10? And this is exactly what we did last problem. So that's parts A, C, and D. Now, does anyone remember what the empirical rule actually is? Okay, so the empirical rule says if you have this normal distribution centered around a mean, mu, the empirical rule says that 68% of your data will, on average, fall between the interval mu minus 1 times sigma, mu plus 1 times sigma. So that's what the empirical rule says. And it additionally says that 95% of the data will fall between mu minus 2 sigma and mu plus 2 sigma. So for us, mu is equal to 8 and sigma is equal to 2. So we want to calculate the probability that we will arrive in class in less than 14 minutes. So 8 times 2, 8 plus 2 times 2 is equal to 12. So what we're looking for is 14. So if you then look, the empirical rule has one more condition, and that says 99.7% of the data will fall between mu minus 3 sigma and mu plus 3 sigma. So if you then notice that 8 plus 3 times 2 is actually equal to 14. So the probability that we're going to arrive in class before 14-minute mark, or whatever I was really asking, is going to be 99.7%, because 14 lands in this interval of mu minus 3 sigma and mu plus 3 sigma. So that's how you would calculate it using the empirical rule. Okay? Actually, if you were to calculate the probability that x is less than 14 on R, you would get 99.8%. So they're almost the exact same thing. So On to the next problem. So, whatever, I'm just gonna give away part A. We're not gonna be calculating any more z-scores. We've done enough of that. So, we'll worry more about part B. Yes, using the empirical rule, that's what you would say. Sorry, we are gonna worry about part A. Don't worry about part B. Part B is that when it asks you for the z-score. Part A is asking you to calculate the quantile. So part A was it saying, well, you're not really omitting it. You don't really care about it in this situation. You're considering all values of x that are less than 14. Yeah, there's also the case that time can't be negative. But Kevin, that's not to say that mu minus 3 times sigma is going to be a negative number. And in fact, in our case, the lower bound isn't a negative number. It's actually 2, because you have 8 minus 2 times 3. Again, you're not really omitting it. You're just saying that when you expand the range to mu plus minus 3 sigma, 14 now falls in that interval. So I'm not really sure what you mean when you say omitting, but I would say no, you're not omitting it. Right, so, okay, let's look at part A. So it says calculate the z-score representing the longest 10% of lengths of songs played on the radio. So what this is asking you for is the 90th quantile. So it's saying calculate me the quantile such that only 10% of songs are longer than it. Or in other words, 90% of songs are shorter than it in terms of length. So the way you can do this in R is use this function called Qnorm. So if you write Qnorm of 0.9, it's going to give you the 90th quantile. And the 90th quantile is what we want. Remember, it's saying the quantile that we want is a quantile such that 10% of songs are longer than this song. Or in other words, this song is longer than 90% of other songs. So the way you can get to quantile on R is to use Q norm of 0.9. And you want to specify the mean and standard deviation, but in this case, I believe